In this session, we shall discuss programming event-driven input. So in this part, first we shall see using the pointing devices. So there are two types of events that are associated with the pointing devices, which is conventionally assumed to be a mouse, but it can also be a data tablet or a trackball. The first event is the move event. Now this event is generated when the mouse is moved with one of the buttons pressed. So if the mouse is moved without any button being held down, this event we call it as passive move event. That is, the mouse button is not pressed, yet you are moving the event. In that case, it comes under passive move event. A mouse event occurs when one of the mouse button is either pressed, it is pressed or released, that is either up or down. A button being held down does not generate any event until the button is released. So what are the informations that are returned when an event is generated? So the first information is the button which generated the event, that is the left, right or the middle. Then it is the state of the button, that is either pressed or released, that is up or down. And after that, the third value is the position of the cursor, and the reference point is here, that is the topmost corner of the window. Yeah, so that is the position that will be returned to us. So three information returned, that is the button, the state and the position. Now, in order to do this, we have a function called glut mouse function, and it will take my mouse as the callback function. And this callback function should have the following type, that is, first one is void, which is the return type. So I'll say my mouse. So then comes the arguments for us, that is the button. Third one is the, second one is the state, and third one is the position. So the position here is written as int x comma y. That is, position is written as either, not either, it is written as both in terms of x and y. That is indicating the coordinate of the x value and the coordinate of the y value on the screen. So this can be written as int x and int y. So this is the arguments. So now if I want to define a function which will terminate the program once the left button is pressed, and if you press any of the other button, then there should be no action taking place. So if I want to write such a function, then what should be written? That means what should be the body? I repeat, the function, when I press the left button, it should terminate. When I press the right button or the middle button, it should remain as it is, or there should be no action performed. For that case, inside the body of this, we shall write it as if button is equivalent to glut left button, and the state is equivalent to glut down, then we need to exit, that is come out from the program. So I'll say exit of 0. So when I execute this function, when I press the right button or the middle button, then there is no action taking place. Whereas if I press the left button, then we are going to terminate the program. Now if I want to draw a program, write a program to draw a small box at each location on the screen where the mouse cursor is located at that particular time, and there the action should take place when the left button is placed. That means when I place the left button, a square should be generated. Similarly, when I move it elsewhere, one more square should be generated. So wherever I place the cursor and press the left button, then it should go on drawing these squares for us as it is. So this is the task for us. And whenever we press the right button, we need to terminate the program. Left button to draw this square at the particular position. That is, if my cursor position is here and if I press the button here, then I need to draw the square here. And similarly, I move here and press my right button, then I need to terminate the program. Now let us see how to write the code. In order to do that, let us start with the main program. So I'll write it as main, which will take two arguments, int argc and character, that is star argv, which is a vector. Inside this we need to initialize the glut. So I'll write it as glut init, takes two arguments, that is ampersand argc and then argv, the two arguments for us within the init, and we know that it is used for initializing. Now let us move to the next instruction, which is the window size for us. So I'll say glut init window size, which in turn will take two arguments, the width and the height. So I'll write it as ww, which is the window width, and then I'll write it as wh, that is the window height. Or you could also write the values directly, for instance something like this. But if you use a general value, you need to define that first in the initial stage. The advantage of using this is that when you resize the window, it adjusts itself. But if you set a value particularly, then in that case, if your object size is huge, then it moves out of the window. But we need to remember that if we are using ww and wh, we need to define that. So in order to do that, let us write somewhere here. I'll write it as gl underscore size underscore I, where I'll say wh is equal to some value. Similarly, ww is equal to some value. Yes. So remember to do that. Otherwise, it would return an error to you because it does not find the definition of ww and wh for us. Either ways is fine in order to write it. Now let us set the display mode. So we'll say glut init display mode. So this will take the argument as glut single, and then also it will take glut RGB, which is indicating that we are making use of a single buffer and the RGB, that is the color buffer. Next, let us go for the creation of the window. In order to do that, we use glut create window, and then let us take the name of the window as square. So here we are creating a window by the name square. Remember, everywhere it has a semicolon. Next, let me write or call one function myInit, which is a user defined function. Let us see what to write into that. Yeah, so and let us write the reshape function that will be generated whenever the output window is resized, that is either increase or decrease. In order to call that reshape function, let us write it as glut reshape function. So I'll say glut reshape function, and this will take the argument which is the function name. I'll write it as my reshape. So if you look at it, we have written initialized it, then window size is done, then we have taken the display moved, initialized the buffers, created the window, we have called the myInit, and after that we have written the reshape function. And now whenever we press the left button at a position, we need to draw the square, and whenever we press the right button, we should terminate. So for that we would require a mouse function. So we will write it as glut mouse function, and this will take one more argument. Let us call it as my mouse. Remember, all of these are user defined functions. Next instruction, let us write the display function, which is the glut display function, and this will take in the argument as one more function. Let us call it as display, which contains all the instructions related to the display for us. If you can see here, we are calling so many functions, that is my reshape, my mouse, and display. Finally, let us end this main with glut main loop, which is the callback function for us. So here are a list of instructions which we have written inside our main function, and the purpose of this program which we are writing is whenever I move the mouse button, the mouse, and click the left button at a particular point or a position, then a square should be generated. Similarly, when I press the right button of the mouse, it should exit from the program. In order to do so, we have written the main part, and within the main part, if you can look at, we have called 3 functions. And here again, to be very accurate, we have taken WW and WH, which stands for W, that is the window width, and window height. Again, you can directly specify the value, or you can take WW and WH, which is your choice. But on the other hand, if you are taking the generalized instruction, then it should be initialized beforehand, making use of it. Otherwise, it would return an error for you. Once all of this is done, let us close the main function. Now, let us first write the display function. Yeah. First, we are starting with the display function, which contains the display parameters or the instructions, I would call. So let us start with void display. You can change this, but however, please remember, if at all you are making use of the name display, then it should match your call also. So I'll say I have no arguments. It's just a call. Then I'll say here GL clear. In this I will set GL color buffer bit and then close it. Let us write only so much in the display function, that is I'm clearing the buffer bit so that if at all I add any new color, that color would be given in. That means erasing all the previous values and ensuring the new color theme is set to the window that I'm making use of. Let us try to keep it minimal, because here our function is not to deal with the color or the beautification of the screen. Rather, it is for a purpose where we are speaking about a mouse event, wherein I know that the click of the left button should generate a square at a position and the click of the right button should terminate the program for us. Now let us move to the next function, which is the mouse function. And what is the name of the mouse function? We have called it as my mouse. So let us write this function, ensuring that when I press the left button, it draws the square, and when I press the right button, it exits. So that logic needs to be enclosed in this mouse function. Let the return type be void, name of the function my mouse, and the number of arguments it takes are 3. So let us say here first one is the button. So I'll say button. Second, it takes the state, that is whether you're pressing down or releasing it. So I'll write it as int state. And third one is the cursor position in terms of x and y. So I'll say int x and int y. So once it is done, let us close this. We will begin with the writing of the content here. Let us write the first condition. If my button is equivalent to the left button. So how do we write this? We write it as glut underscore left underscore button. So what is the condition for us? It is the left button and it has to be pressed down. So I'll say state is equivalent to glut underscore down. So if this is the case, then what do I need to do? That is, if the button is left and state is down, then let us call the function draw square. And where should it draw? That is wherever my square is, and if I'm pressing it at that position, then it should draw. That means I have to press it. The state should be pressed down. There it should draw the square. For that, I need to pass the value of x and y, saying at this position, the square should be drawn. So this will complete the left button part. Now let us see the second condition. What is the second condition for us? If button is equivalent to the right button. So how do I write it as? Glut right button. And what is the second condition for us? State should be equivalent to glut of down. And in this case, if the condition is true, then we say exit. So both the condition are written. Now let us close the function. So what have we done here from, that is, which is deviated from the main function my mouse? Here we have written two instruction. One is associated with the left button and the other one is the right button. Okay, and left button says that when you press it down at a particular position, you're invoking the function draw square. On the other hand, right button says that if it is pressed down, then we exit. Now, here if you can see, we have called a function called as draw square. Let us see what to write in that draw square. Let us take the return type as void draw square, no space here, and it will take two arguments. Which are the two arguments? It is x and int y. That is the position. Here we do not have semicolon because it is the function definition. Now let us come to the body. Here first let us begin by setting the position with respect to the window. So in order to do that, I'll write y is equal to wh minus y. Now I have to draw the polygon. So in order to draw the polygon, what do we write? GL begin, and we will write it as GL underscore polygon. So this will create a polygon for us. And what should I have with this? At the end, I should have an GL end. And along with this, I also need to have a GL flush. Yes. So these are some things which are associated when we make use of GL begin. Let us also close this, indicating that my draw square completes here. Now let us see what we write inside this. What is it? It is to draw the square. So let us see what are the instruction. First, I'll write it as GL vertex to F. Yes. So we have always seen that when we make use of this, we need to write the vertex coordinates, which is written with the help of GL vertex to F. Now, even before we go there, let us write the size of the square. So in order to do that, first let us define. In order to do so, we will say in the beginning, that is, let me say here, GL float size is equal to 30. You can take your own size. It is not a mandate that you have to take 30 here. It is up to you what size you take. Yes. So I'll here take it as x plus size, and I'll write y plus size. And next I will write it as GL vertex to F, that is x minus size and y minus size. And the third one is I will take it as GL vertex to F, x minus size and y minus size. And the last one, I take it as GL vertex to F, x plus size and y minus size. So I've written 4 instructions here. One is, all 4 are of type where we are defining the vertices for the square or the polygon that we are generating. If you can see, we have 4 vertices. So we have written 4 times GL vertex 2F, floating point values. Here I've taken x plus size, where I've already defined size as float type, and I've set the size to 30. As I said, it is up to you to decide the size of the object that you are trying to draw. Now, why or how are we writing all these four values? If you take the square and if you take the xy position, this will be x plus size and this will be y plus size, and this will be x plus size and y minus size, and this will be x minus size and this will be y plus size, and this will be x minus size and y minus size. Let me just go back to the instruction. So if you can see, the first one we have written it as x plus size and y plus size. The second one we have written it as, sorry, this has to be x plus size and y minus size. Just take this, you will understand. If this is my, here I have both positive x and y. Here this portion we have the negative y and the positive x. So this becomes x plus size and y minus size. Similarly, the next one which I have here, which is here x minus size and the y minus size. And lastly, I have this which should be x minus, so this should be x minus size and y plus size. Yes, so these are the values which we have taken: the first quadrant, second quadrant, third quadrant and the fourth quadrant. So these are the way in which, or this is the way in which the coordinates are written, such that it will work whenever I point my mouse and press the left button. Now, the last remaining function for us is my init. So now let us see what we have within the my init function. So in order to do so, I will write it as void my init. So here, let us see what do we write. First, we will write GL viewport, which will take 4 arguments, that is the xmin, ymin, xmax and the ymax. So these are the 4 values that it will take. So here this ww and wh, we have already defined it within the main function. If I have written whatever values, that will be assigned. If at all you have not defined, then you can write the number. That means it would look like this: 0, 0, 500 and 500. Whatever number you want can be taken. Next, I will set GL matrix mode. I will set the argument as GL projection. And next, we start with loading the identity matrix. And to do so, we will write it as GL load identity. So this will load the identity matrix for us. Next, let me write it as GL ortho 2D. This ortho 2D will take in again 4 arguments, which is x min to x max and y min to y max. So let me write the arguments, that is x minimum, y minimum, x maximum, sorry, y minimum to y maximum. So I'll write it as 0.0. Basically it's a double value, so I'll write it as 0.0, and then let me convert whatever I've taken into a double value, because I've just taken it as size and there I think we have taken it as int. So in that case, it would be an integer value, and here we know pretty much it's the double value. So let us convert it into double. What are we converting it into double? The maximum values which we have specified in the form of a variable. So I'll write it as GL under GL double of W and similarly 0, 0 and then GL double of WH. Next, let us set the matrix mode, that is, I'll say matrix mode to GL model view. I hope all of you remember the initial discussion we had in the initial classes. We said that the matrix mode is set to projection when I'm using it for the first time. I think I've taken an example of where, if at all I have a blueprint of any of the object, or let's say a house for that matter. First time I would have no reference at all. So first I will project it saying this is how it looks. That is our GL projection here. Next time onwards, when I want it, I already have the model view. I don't have to go for the projection. So I'll say it is already existing, make use of it. Then it becomes GL model view for us. Next, let me write GL clear color, where I'm writing all three as 0 and the last alpha value as 1. So whatever is the color specified here, that is the color which will be given to your window. So I have written alpha value 1.0. Now next, let us go and set the color, where I'll say color 3F. So I'll say GL color 3F, where we are defining a new color, saying that I want it in the red color. So I'll say 1.0, 0.0 and 0.0. This, if I close it now, completes the init function for us. So if you can see, initially from main, we have deviated a lot, wherein we have visited numerous functions, which in turn would be performing different actions. Yes, so I think this helps us understand the mouse event for us. Yes. Hopefully till here we are all clear, wherein we were discussing about the pointing devices, and then we said that the pointing devices has two events. One is the pressed event, which is the down action, and the other one is the released event, which is the up action. So these are the two events that are associated, defined. And in order to get this event done, we have three buttons, that is the left button, the right button and the middle button. So understanding that, we tried to generate a program in order to get the following action. The action was, if I use the left button at a particular position and press it in that position, it should draw a square, a polygon. And if I use the right button and press it at a position, then it should exit. I think pretty much we have captured what we were trying to analyze. Yes, next let us move and understand the next topic, which is, okay, now let us go and understand what are the different window events that are available for us. Window events, whenever the resizing of the window is done interactively by either dragging the mouse, that is pointing it at the corner, and dragging, that is, if I have this here, if I drag this, it either increases the size or decreases the size of the winding. So this we call it as resizing. That means, and if we perform this, then we call it as the window event. And if at all such an event occurs, then we consider three cases. That is, first one, whenever I am changing the size of the window, should I redraw all of the objects that are in the window before it was resized? So this is the first question that we have. Yes. Second question is, what do we do if the aspect ratio, that is the image height, is different from that of the old window? So I'll say aspect ratio. That is, if this is my original window and if I'm resizing it, then if at all my aspect ratio remains the same. Okay, this is something like where you have equally increased. On the other hand, you could also drag it this way. In this case here, this will be the image that I have. In this case, the aspect ratio is changed. So in such a case, what should I do? Now, if I'm having a circle like this, should it be drawn as elongated, or what is the action that should be taken if the aspect ratio of the new window is different from the old window? And the third case is, do we change the size or the attributes of the new primitives if the size of the new window is different from that of the old window? That means we have to look into the attributes. Here we have to look into all the three cases and then decide on what needs to be done. Now let us see how to do this. And this will be done here within void my reshape function. Okay. That is, in order to consider all of these three parameters, we write a function called as my reshape function. And this will take two arguments, that is GL size of I for the width and GL size I for the height. So this takes two arguments. Now let us see if we have to adjust the clipping window, and in order to do so, we have to set the GL matrix mode to GL projection. Next, we will set the identity matrix, which is GL load identity, and then comes our GL ortho 2D. Here I have the X value first, minimum, maximum. It's of type GL size I. So let us convert it into double. So in order to do that conversion, I write it as GL double, the explicit conversion of the width. Similarly, the Y minimum value, and then conversion to double for the Y maximum value. That gives the height for us. Now, the next instruction we will write after all of these changes is the GL matrix mode is set to GL model view. Yeah, indicating that we have the basis. Now after that, let us write again GL load identity. So here, if you can see, I've started with the matrix. Initially, I wrote a function name with the arguments followed by matrix mode saying that I'm trying to draw something or do a task. Then we load the values, we set in some new values and then say that has to be adopted to the existing model and load those values. Once that is done, let us write the viewport. In order to write the viewport, let us write it as GL viewport, and that is written as 00 W and H. Yes, now if I want a new window height and width, I think instead of going to the next screen, I'll just draw it here itself. So I mean, I'll write it here itself, where you can write window width is equal to W and window height is equal to height, and then you can continue. Close this here. So the order is as. Now let us move on in order to understand the keyboard events. And even before I go into it, please remember here we have discussed the window events. Window events mainly are associated with resizing. Resizing can be done in three different ways for you. One is where you drag it equally. Here is the image for us. The other one is that does not distort. That means X and Y value equally increases. But here, if you look at this here, only the height has increased, the width has no changes into it. So that is one way. Similarly, the other way is where you drag it this way, it just increases the width, but the height remains the same. These are the three ways in which you would resize. When you do this, there are three things that has to be taken care of. What happens to the object, I mean the contents or the objects that are present in the window? Should it redraw and adjust it to the new size? And then comes the aspect ratio. Aspect ratio deals with these two cases for us, and then the attributes. In order to do so, we have written a code here which tries to tell us what is the different things, or what are the different things that needs to be considered. We have written a function called as my reshape, wherein we have taken the width and the height and then the different aspects in order to set a new width and height. So far we have discussed the mouse events, of what we have called as the pointing devices events, and then we have spoken about the window events. Now let us move further in order to understand the keyboard events. These events occur whenever the user presses the key of the keyboard or keys in the input. That means in order to give any input, the user has to press the button of the keyboard, which in turn will generate an event for us. Remember, keyboard events are generated when the mouse is in the window where you are defining and where you are going to press or release any one of the key. So in order to do so, we will say glut keyboard function, and it's a callback function for us. That is, this is a callback function for the events that is generated by pressing any of the key of the keyboard. Similarly, we have glut keyboard up function. Similarly, we have a down function also. Again, this is also a callback function. The glut keyboard function is used for pressing the key, and this second one is for releasing the key. Whenever you press a key, the ASCII code is generated and the location of the mouse is written. All the keyboard callback functions are registered in a single callback function, which is called as the GLUT keyboard function, which is a single callback function where all the other functions are registered. When I say all the other function, it is the keyboard callback functions are registered. Now, what should be written in this MyKey? This takes in 3 arguments. One is the character which you are going to press. Second one is the key. The third one is the position. So that is, it will take void my key, and inside this I'll write unsigned character and the position, that is int x and int y. So this is our MyKey function. Inside this, let me write if, let us say I'm going to write it with respect to q. I'll write key is equivalent to q, that is the lower case, or the key is equivalent to q, that is the capital letter. And let us say the action that we are trying to write is the exit or the termination action. So I'll write exit of 0. Yeah. So here, if you recall, we started off with the keyboard events. We said that a keyboard event occurs when we press or key in any of the keys in the keyboard. We have defined 2 callback functions in relation to the releasing of the button and the pressing down of the button. This is for pressing the button and this is for releasing the button. And all of these, basically these 2 are the callback function. And we have said that all these callback functions can be present in a single callback function, which we called it as the GLUT keyboard function. And in order to understand the working nature, we said GLUT callback functions invoke, it will invoke any user-defined function wherein the user writes his or her preferable code in it. Next, the GLUT also includes a function, GLUT modifier function, which enables the different functions for us. Just to recall this MyKey, we will say when we press the lowercase or uppercase q, we exit from the function. Similarly, we have the display and idle callbacks. After all the 3, that is the pointing devices, then we spoke about the window events. Next, we spoke about the keyboard events. Moving further, I'm discussing the display and idle callbacks. So if you recollect the programs that we have written, we have very commonly been using one function, that is GLUT display function, with the argument usually being as display. This is invoked whenever the GLUT determines whenever the window should be redisplayed. So display events will be generated when the window is first opened, and the another one happens whenever there is a resize event happening. Display callback can be used in other contexts such as animations, where various values defined in the program changes, or interactive or animation programs will contain many calls for the execution of the display function. We also have another function called as glut post redisplay. So this is one more callback function. This is used in order to avoid unnecessary screen drawings by setting the flag inside the main loop. That means it says that the display needs to be redrawn. Instead of writing instruction many times in order to redraw a window, you just invoke this function. It ensures that the display will be drawn only once when the program goes through the event loop. The idle callback is next. Moving to the second part, the idle callback is invoked whenever there is no other events happening. Let me recollect. We started off with the display and the idle callbacks. Here we have written two callback functions. One is the display function, which we said that which is mainly associated with the display aspect. That is, whenever you have some display set of instruction and it has to be displayed on the window, then we make use of the display function. Let us say I have to invoke this display function multiple number of times. Instead of saying I'm going to call this function or I'm going to write this function multiple number of times, we make use of post redisplay. So each time your main goes through a loop, this post redisplay will display the function, that is the display function again. Moving further, we are going to the idle callbacks. These two are related with the display. In idle callbacks, basically the function is invoked when there are no other events. And here the default is the null pointer, and the typical function of the idle function is to continue the graphical primitives when nothing is happening. That means all the works are done, but still it has to go on. That means all your callback functions are executed, and then yet you want the things to move on. That is, your primitive should continue. In such case, that means no other specific events are existing. In such case, we make use of the idle callback. That is, when nothing exists. Yeah. Next, we have the functions related to the window management. In window management, basically here the GLUT contains instruction which supports the management of the windows, which is in relation to the multiple windows or in relation to the sub windows. That means all these management issues occur not when we just have a single window. When we have a single window, we write all those instructions which we have been discussing and seeing till date. That is, all your display function, the resize, reshape, etc., and post redisplay, etc., and all those things. But when I have multiple windows, they need to be taken care of. There comes the management for us. So I'll say GLUT supports window management when I have multiple window or when I have sub window, that is a window with another window. We have already seen the function GLUT create window, and we know that this creates a window with a specific name given, and it will return an integer value which returns the window ID. And this is helpful when I'm using or creating the multiple windows. So this ID allows us to select the current window or whichever window I want. Yeah. Now I can set any window as the current window by using the function glut set window, which will take one argument, that is the ID. Yeah. So we can make this window have different properties from that of the other window by invoking the function glut init display mode. So here you are going to use this in order to set the properties before using the glut create window. If you use glut create window, then you cannot set the properties. So I'll say first set the properties and then go for the creation of the window. And so here, if you look at, we have discussed with the window management, wherein we said that the management occurs when we have multiple windows or a sub window, that is one window in the other. In order to do so, first of all, in the first place, to create a window, we know that we make use of glut create window with a name given to the window. So this becomes the name of the window. Here it returns an integer type, which is an ID for that window, and this ID is useful and also unique, which will help us select the window if at all I want to work on a particular window when I have multiple windows. And in fact, we can set different properties to each window, making use of glut init display mode, and set the properties to that particular window. Now let us see, or let us discuss the next topics, which is the menus. If you recall, we have discussed menus briefly in our Bezier curves. In order to do so, it is the glut which provides the options for us, and this glut provides the pop-up menus for us, which can be used with the mouses in order to generate the interactive applications. Yeah. I repeat, glut provides an additional feature, pop-up menus, and that can be used with the mouse. That is, whenever you click the left, right, or the middle button, you generate a menu, and used for in creating the sophisticated interactive applications. So whenever I'm using the menus, it involves few steps. That is, you need to follow few steps. First one is you need to define the action, yeah, which is corresponding to each entry in the menu. Yeah. So I need to define the action corresponding to each entry in the menu. The second step is I need to link the menu to a particular mouse button. It could be either the left, right, or the center button, but however, you need to link it to a mouse event. Yeah. And the third step is you need to register a callback. Yeah. So the third one is register a callback function for each menu. So these are the simple steps that needs to be followed while using the menus. Now let us see which are the different functions that are available in order to generate this menu. First one we have is the glut create menu, and this will take a function. That means you need a function here. I'll say demo underscore menu. Yeah, so here I'm writing the first function, that is the glut create menu for us, with an argument as some function name where I've called it as the demo menu. Here if I want to create a menu like this, let us say this is my menu. If my first option is 1, then I need to quit. If my option is 2, let's say I want to increase the size, and if my option is the next one, then I need to decrease the size. Let's say this is the menu that I want to write, and I want to add each of the menu entries into the menu which we have just created. For that we have the function glut add menu. Just a second, let me erase this for you and say I have this menu wherein first option is quit, second is increase the size, third one is decrease the size. So we said this is the menu generated for us by making use of glut create menu, and this is the name of the menu given. Rather than calling it as a function, I'll call it as the name of the menu which is being created. And in that we need the items or the options. In order to do that, we have the function, let us say glut add menu entry. Please make note of the capital letters, and it is case sensitive for us. We cannot write it in any way we want because they are all user defined. And what is the first option for us is quit, and the option taken is 1. Next I'll say glut add menu entry. I'll say I need to increase the size of the object, and the option is 2. Next, third one, let us write it as glut add menu entry, and let us say it is to decrease. So I'll say DC decrease the size, and the option is 3. Once the options are added, it has to be linked. In order to link it, let us say glut attach menu. So I'll say I have this function glut attach menu. So this will basically attach the menu to the mouse. So inside this I write to which button I need to attach. So I'll write it as glut right button. So what I'm trying to say is whenever the right button is clicked, then this menu should be displayed. So these are some of the important commands to remember whenever you're making use of the menu. Basically this glut create menu registers a callback function demo menu. Now let us see how to write that. So let us write it as void demo menu. Yeah, so here we have a callback function which is the demo menu, which is associated with create menu. So I've written it as void demo menu, and this takes the arguments, that is int. So I'll say id. Basically, what is this id? It is nothing but your 1, 2 and 3, the values associated with the different entries that you have put up in the menu. So that becomes the argument of your demo menu. Now let us write here the switch case associated with the id. Here let us write it as, if the case is 1, then I'll say exit of 0, and then I'll say break. Next, if the case is 2, then I'll say I need to increase the size. So I'll say size is equivalent to size into 2. That is, I'm doubling the size here. After that, let us break. Okay. Next, I'll say case 3 is, I want to reduce it to half. So I'll write it as size is equal to size divided by 2. So this reduces the size by half. Now if I'm making use of size, I need to make sure that the size is always greater than 1. So in order to ensure that, I'll say that you can write a condition, if the size is greater than 1, then you perform this. Yeah, if you want you can add, otherwise just ensure it. Now once you're done, close this. Next, I'll write the instruction glut post display. Yeah, and then let us close the main function. Now you may ask me, why this post redisplay? Say first you increase the size. You have an object whose size is increased. Yeah, or let me start with, I have an object here. Let me take an example of the window here, and within the window, let's say I have this object. Now I've pressed the key 2. So what happens? The size of the object increases. Now fine, the size of the object is increased. After increasing the size of the object, what should happen? That increased sized object should be placed into the window. In order to do that, I have to recall or call back my display function. So here I say post redisplay. If you recall, we said that post redisplay is when I have a display function which is being called multiple number of times. Instead of writing different display functions again and again, I just make use of this post redisplay. So this will call this window again with what? With the size of the object increased. Yeah. Now, recollecting, we have understood how to create the menu, generate the items into the menu, and then how to register it with the mouse, and then how to define the callback function. Here remember, glut post display, it requests to redraw the window whenever a change is made, and it ensures that it does not draw the menu again. Now let us see how glut supports the hierarchical menu. Let us see what is that hierarchical menu. That is, let's say in my menu I have this quit, yeah, and next I have resize. Next, when I click resize, I have two options. One is I have to increase the size. The other one is decrease. This is either double the size or reduce to half the size. If at all I want to create this hierarchical structure, then This is also supported in our graphics. Let us see how to do this. First, let us create a menu. So in order to do so, we have glut create menu, and let us call it as size menu, and let us store this id in a variable called as sub menu. So this becomes the id of this menu. Now in order to add the entries, what we need to do, glut add menu entry with two arguments. One is increase, that is the string, and the number, which is the second argument. Next, let us add glut add menu entry, that is to create one more entry. So I'll call it as decrease, and then I'll say the option is 3. Let me create one more menu here, glut create menu, which I'm calling it as the top menu. Now here I need to add the entry. So let us call it as glut add menu entry, and here the string is quit for us, and the number associated is 1. So here we have 1, 2 and 3. Now here we need to attach the sub menu into this main menu entry, that is here. In order to do so, we will write it as glut add sub menu. So this will create a sub menu with the name of what, or where it should be added. It should be added as resize. So I'll say this should be added to resize. And next I'll say this should be attached to what, this increase. So I'll say sub menu. Yeah. Next, this entire thing should be attached to the mouse. So I'll write it as glut attach menu, and then whichever is your button. So let's say right button. So glut right button. Yeah. So it should be attached here. So this becomes the code for the creation of this menu for us. So what we have done, we have gone for the creation of the hierarchical structure, wherein we have said that first create the menu with the argument as size menu, and it is attached to an ID here. Yeah, after that we have made the entries into the menu, which is nothing but the increase and the decrease option, that is here, this increase option and the decrease option. After that, I need, it is just for this resize and increase and decrease, or rather I will say it is only for this increase and decrease we have created the menu, because that also should look like a menu for us. Now I want this portion. In order to do so, let us say create menu top menu. So that creates this menu for us. This instruction creates this menu for us, whereas this instruction creates this menu for us. Yeah. Now here, what do I need to add? I need to add the option quit. So let us do that by using glut add menu entry quit with the value as 1. So this option is generated for us. Now we need this resize option. So that contains submenu. So for that we write it as glut add submenu. What is that name that we require, or the string that we have? Resize. And then attach the ID which contains this submenu. And what is the name of that ID? It is called as submenu itself for us. So I'll write the second argument as sub menu. So basically sub menu is attached to this resize option. So once that is done, now we have to link it to the mouse action. How do we do that? We attach it by using the function glut attach menu, and the argument is the button with which you are trying to attach or generate that menu. So here in my case, it is the right button. So this finishes the discussion on menus for us, wherein we went on to see the creation of the menus and in the second instance, the creation of the hierarchical menus. Thank you for learning.